Good day to ladies and gentlemen. My name is Yang Shuyi. Today I'm going to talk about CFD simulation of the performance of retrofitted cyclone separators at Varai Retrofit Dimension. I am supervised by Dr. Ruwaida and Dr. Devika. For overview of this presentation, it includes introduction, problem statement, objective, methodology, and result. In the current world today, the air that we breathe in is gradually being polluted against the rapid rising against the development of the world economy. This is a fact that can't be denied. According to the World Health Organization (WHO), is the largest environmental health risk as air pollution kills an estimated 7 million people worldwide every year. Statistically shows that 50% of the world air pollution today comes from industrial activities. Many of the source of pollution comes from such as burning of fossil fuels of manufacturing industries, mining, and coal and gas-fired power stations, which are the source of air pollution. In this context, we will focus majorly on one of the causes of air pollutants, which is particulate matter. Particulate control devices like cyclones, electrostatic precipitators, baghouse, and scrubber remove fly ash particulates from flue gas for subsequent collection and beneficial use or disposal. Out of all the particulate control devices, cyclone separators are among the least expensive. Cyclone separators, or simply cyclones, are separation that use the principle of inertia to remove particulate matter from flue gases. The advantages of cyclone separators are low capital cost, its ability to operate at high temperature, low maintenance requirements because there are no moving parts, and it can handle dry collection and disposal. For cyclone classification, it can be classified into single cyclone separators, multi-cyclone separators, and also retrofitted multi-cyclones (RMC). We all know, in fact, that the air pollution problem is repetitive each and every year. The air pollution index is going up unless we change the approach to the problem. Current technology such as conventional multi-cyclones (CMC) are installed in the industry as the particulate emission arrestor. However, conventional multi-cyclone CMC is not effective in removing fine particulates, especially PM2.5 and below. The collection efficiency of the existing multi-cyclones was found to be 68% only, indicating the inefficiency of the existing unit in the capture of particulates, especially the fine size fraction. Several designs should be considered to achieve the optimum combination of collection efficiency and pressure drop. In a previous study, modification was done to the original pilot plant, which is known as CMC. The modified one is known as Retrofitted Multi-Cyclone (RMC). The retrofit is an additional suction inlet pipeline, which was well at the bottom end of the cyclone dust outlet. This is to ensure that the airflow created in the suction line pulls out particulate from the vortex. Surprisingly, the overall collection efficiency of RMC was higher by 9 to 16% compared to CMC with the particulate emission. In this study, the suction stream will be redesigned with different dimensions to test whether which dimensions will give the best collection efficiency. For the objective, the three main objectives are as below, which is to redesign the suction stream with different dimensions using SolidWorks. The second objective is to apply CFD simulation at the various designs, and the third objective is to compare the phenomena on both the original and redesigned retrofitted cyclone. The scope of works under Objective 1 are to redraw with SolidWorks for the new retrofit design, and existing retrofit dimension is circular 2 inch. To change the retrofit with rectangular 2 inch by 2 inch and circular 3 inch, for Objective 2, we have to study and understand the original retrofit of the cyclone using CFD and re-simulate the cyclone performance on the new design using CFD. While for Objective 3, we have to compare the particulate trajectory, velocity contour, and pressure contour between both designs and determine the best design. For the methodology part, the first stage is to develop the 3D drawing of retrofitted multi-cyclone RMC with different dimensions of suction stream by using SolidWorks, while at the second stage, the application and verification of CFD are done with the results to be compared and verified with the previous experiment values by using computational fluid dynamics CFD to ensure the accuracy of the result. For the third stage, performance comparison was done by fulfilling objective 3, which is to compare the particle trajectory, velocity contour, and pressure contour, as well as predicting the collection efficiency with different dimensions of retrofit. For SolidWorks, before you actually design the model, it is helpful to plan out a method of how to create the model. After you identify needs and isolate the appropriate concepts, you can develop the model by using sketch, features, and assemblies. A model almost always includes one or more sketch and one or more features. However, not all models will have to include assemblies. For the workflow of the CFD and SYS Fluent V20, it will be separated into 3 stages, which include pre-processing, soft, and post-processing. Under pre-processing, geometry and mesh will be created. The physics model will be selected in the physics setting, and solver will be selected. Under the soft stage, the solution will be computed based on a computational algorithm. Under post-processing, results will be examined and verified with the results obtained from previous study. Not only that, contour plots and particulate trajectory results will be generated. While for the details of setting in CFD, the 3 types of retrofit, which including circular 2-inch, rectangular 2-inch, and circular 3-inch, are set with the same condition. The target mass flow rate is set at 0.2223 kg per second. The pressure inlet, pressure outlet, suction pressure outlet, and suction mass flow rate were set as the same condition for all 3 types of retrofit. In spatial discretization, the solution controls are set as below. In result part, the 3D sketching of solid overview of 3 different types of retrofits are shown for circular 2-inch, rectangular 2-inch, and circular 3-inch. And this is the 3D sketching of solid overview in retrofit for 3 different types of suction stream. This is the surface mesh generation with element size of 0.15 meter for 3 different types of retrofit. The more detailed a mesh is, the more accurate the 3D CAD model will be, allowing for high fidelity simulations. For the result validation, the inlet static pressure and outlet static pressure were obtained for suction 10% and 20% for Cyclone flow rate of 0.11 m3 per second and 0.19 m3 per second. The difference between CFD and experimental is less than 10%, indicate that the CFD model has achieved convergence with good accuracy. It can be observed that Cyclone with retrofit of circular 3-inch has greater collection efficiency compared to that of circular 2-inch and rectangular 2-inch for PM1, PM2.5, and PM10. Besides, we can see that the particles escape from suction stream of retrofit with circular 3-inch is higher than retrofit with circular 2-inch and rectangular 2-inch. From the graph of separation efficiency for suction 10% and 20%, we can determine that retrofit with circular 3-inch have the best collection efficiency compared to the others. For the pressure contour, it is the same for 3 different types of retrofitted cyclone, as it is also set at the same boundary condition for all. We observe that the higher the suction percentage, the more negative pressure were created for inlet stream, outlet stream, and suction stream. For the velocity contour, the velocity will rise as the dimension of suction stream will rise. It will observe the higher the suction percentage, the higher the velocity of gas at inlet stream, suction outlet, inlet vortex, and cyclone vortex. By comparing the velocity of gas at suction outlet, retrofitted cyclone with circular 3-inch has the highest velocity compared to that of circular 2-inch and rectangular 2-inch. This also explains why the particle escape from suction stream in circular 3-inch is the highest. For the particulate trajectory at suction 10%, we can observe that the bigger the particle size, the higher the inlet velocity, as heavier particle processes greater inertia, while the vortex velocity decreases as the particle size increases. This is because the bigger particles tends to have greater wall friction and it will slow down when passed through the swirling flow at vortex. Not only that, as the particle size increases, the particles escape from outlet stream also decreases because of the greater gravitational force for higher particle size. In overall, the retrofitted cyclone of circulatory inch has the highest velocity compared to the others, which results in better collection efficiency as well. While, as the suction percentage increases, the velocity of gas at inlet stream and cyclone vortex also increases. For the particle velocity by size in dust hopper and suction stream at suction 10%, we observe that the higher the particle size, the higher the velocity at suction stream. We also observe that the particle escape from suction stream is the highest for retrofit with circulatory inch. While as the suction percentage increases, the velocity of gas at suction stream also increases, with higher particles trapped in dust hopper and higher particles escape from suction stream as well. The third objective has been fulfilled as the suction stream were redesigned with different dimensions using SolidWorks. The CFD simulation were applied at the various design and the phenomena were compared on both the original and redesigned retrofitted cyclone. The dimension of retrofit plays an important role in affecting the collection efficiency of cyclone and particulate velocity by size in the suction stream. And the retrofit of circulatory inch has greater collection efficiency compared to that of circular 2-inch and rectangular 2-inch for PM1, PM2.5 and PM10. Particles escape from suction stream of retrofit with circular 2-inch is higher than retrofit with circular 2-inch and rectangular 2-inch. In conclusion, retrofit with circular 3-inch has greater performance compared to retrofit with circular 2-inch and rectangular 2-inch. And that's all from me. Thank you for your attention.